Welcome all of you to the chemistry online classes as we are discussing about the study of the structure of the atom. So you know that atom consisting of the subatomic particles like proton, neutron, electron, and the arrangement of such a subatomic particles in an atom is given by many models. Okay, many models, many scientists, they have studied on the structure of the atom. There many discoveries has been happened. So several models came during the discovery of the structure of an atom. So all those models play an important role in that J.J. Thomson model and then Rutherford atomic model. These models are in order to find out the structure of an atom. Not already they have discovered proton, neutron, electron. How these are arranged inside an atom, that should be given by many models. Like J.J. Thomson, he conducted an experiment. He studied regarding the structure of atom. He said few of his ideas regarding the structure of the atom, and later on Rutherford also one of the important scientists. His discovery is also very important, and later on we accepted that is Bohr's atomic model nowadays. And there are certain developments happened during the Bohr's atomic model was formulation, or it is formulating. See here, in today's class we want to discuss about the developments leading to the Bohr's atomic model. So the Bohr's atomic model is there for your syllabus and the previous models, they were deleted from your syllabus. The previous models helps the Bohr, the scientist Niels Bohr, to predict his atomic model or to propose his atomic model. So what are the developments happened during his atomic model? Ideas were given by him. So see here, first of all, the interaction between any matter and radiation, the interaction between any matter and radiation contributes a important idea regarding the structure of an atom. It itself contributes something regarding the structure of an atom. When he took certain matter and he introduced that matter into the radiation, that radiation when those are passed through a matter, there are certain observations has been happened, those observation contributing the structure of an atom. Andreri ಏನಾಗ್ತದಪ್ಪ, ಯಾವುದೇ ಒಂದು ಮ್ಯಾಟರನ್ನು ರೇಡಿಯೇಷನ್ ಜೊತೆ ಇಂಟ್ರಾಕ್ಟ್ ಮಾಡಿದಾಗ ಅದು ಕೆಲವೊಂದಿಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಅಬ್ಸರ್ವೇಷನ್ ನಮಗೇನು ಬರ್ತೈತಿ, ಕಂಡು ಬರ್ತೈತಿ. ಆ ಇಂಪಾರ್ಟೆಂಟ್ ಅಬ್ಸರ್ವೇಷನ್ ಒಂದು ಸ್ಟ್ರಕ್ಚರ್, ಆಟಮ್ದ ಸ್ಟ್ರಕ್ಚರ್ ಹೆಂಗೆ ಅಂತ ಹೇಳಿ ಒಂದು ಮಾಡೆಲ್ ಪ್ರಿಪೇರ್ ಮಾಡೋಕೆ ಹೆಲ್ಪ್ ಆಗುತ್ತಾ. ಸೊ ಮೇನ್ಲಿ ಟೂ ಮೇಜರ್ ಡೆವಲಪ್ಮೆಂಟ್ಸ್ ದೋಸ್ ಕಾಂಟ್ರಿಬ್ಯೂಟೆಡ್ ಫಾರ್ ದ ಬೋರ್ಸ್ ಅಟೋಮಿಕ್ ಮಾಡೆಲ್. ಎರಡು ಮೇನ್ ಡೆವಲಪ್ಮೆಂಟ್ ಏನಾದ್ರು ರೀ ಬೋರ್ಸ್ ಅಟೋಮಿಕ್ ಮಾಡೆಲನ್ನು ಪ್ರಪೋಸ್ ಮಾಡೋಕೆ ಹೆಲ್ಪ್ ಮಾಡಿದ್ದು. ಸೊ ಹಂಗಂದ್ರೆ ಎರಡು ಮೇನ್ ಮೇಜರ್ ಡೆವಲಪ್ಮೆಂಟ್ಸ್ ಯಾವುದಪ್ಪ? ಫಸ್ಟ್ ಒನ್ ಈಸ್ ದ ಡ್ಯುವೆಲ್ ಕ್ಯಾರೆಕ್ಟರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ರೇಡಿಯೇಷನ್. ಸೊ ಎಲೆಕ್ಟ್ರೋಮ್ಯಾಗ್ನೆಟಿಕ್ ರೇಡಿಯೇಷನ್ದು ಡ್ಯುವೆಲ್ ಕ್ಯಾರೆಕ್ಟರ್ ಇರ್ತೈತಿ. ಡ್ಯುವೆಲ್ ಇಟ್ ಸೆಲ್ಫ್ ಇಂಡಿಕೇಟ್ಸ್ ಟು. It means the electromagnetic radiation behaves like a wave and even it behaves like a particle. So the dual nature of the electromagnetic radiation, it means the electromagnetic radiation can behave like a wave and even it can behave like a particle, and this is one of the major development which helps for the Bohr's atomic model. And one more point is regarding the atomic spectra. When the spectrum of an atom is observed during that time, that also helps or that also contribute to the Bohr's atomic model. ಸೊ ಏನಪ್ಪ ಇವೆಲ್ಲ ಅಂದ್ರೆ ಬೋರ್ಸ್ ಅಟೋಮಿಕ್ ಮಾಡೆಲನ್ನು ನಾವು ಈಗ ಒಂದು ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಮಾಡೆಲ್ ಆಗಿ ಕನ್ಸಿಡರ್ ಮಾಡಕತ್ತೀವಿ ಅಂದ್ರೆ ಆ ಮಾಡೆಲನ್ನು ಪ್ರಿಪೇರ್ ಮಾಡುವಾಗ, ಆ ಮಾಡೆಲ್ ಬಗ್ಗೆ ತನ್ನದೇ ಆದ ಪಾಸ್ಟುಲೇಟ್ಸನ್ನು ಕೊಡುವಾಗ ಅದ್ರ ಬಿಹೈಂಡ್ ಕೆಲವೊಂದಿಷ್ಟು ಡಿಸ್ಕವರೀಸ್ ಆಗಿರ್ತಾವೆ. ಸೊ ಆ ಕೆಲವೊಂದಿಷ್ಟು ಡಿಸ್ಕವರೀಸ್ ಎದಕ್ಕೆ ಕಾಂಟ್ರಿಬ್ಯೂಟ್ ಮಾಡ್ತಾವ್ರಿ? ಬೋರ್ ತನ್ನ ಐಡಿಯಾನ ಒಂದು ಆಟಮ್ ಸ್ಟ್ರಕ್ಚರ್ ಬಗ್ಗೆ ಹೇಳಲಿಕ್ಕೆ ಹೆಲ್ಪ್ ಮಾಡ್ತಾವೆ. ಸೊ ಆಲ್ ದೀಸ್ ಆರ್ ದಿ ಡೆವಲಪ್ಮೆಂಟ್ಸ್ ವಿಚ್ ಹೆಲ್ಪ್ ಫಾರ್ ದ ಸೈಂಟಿಸ್ಟ್ ನೈಲ್ಸ್ ಬೋರ್ ಟು ಪ್ರಪೋಸ್ ಹೀಸ್ atomic model. Clear? So these are the certain points which helps for the Bohr's atomic model. So later on there was one scientist called as Maxwell. Okay, James Maxwell theory of the electromagnetic radiation, or it is also called as Maxwell's wave theory. ಸೊ ಮ್ಯಾಕ್ಸ್ವೆಲ್ ಅನ್ನುವಂಥ ಸೈಂಟಿಸ್ಟ್ ಅವರು ಒಂದು ವೇವ್ ಥಿಯರಿಯನ್ನು ಹೇಳ್ತಾರೆ. ಸೊ ಏನು ಹೇಳ್ತಾರಪ್ಪ ಅಂದ್ರೆ, ದ ಸೈಂಟಿಸ್ಟ್ ಮ್ಯಾಕ್ಸ್ವೆಲ್ ವಾಸ್ ದ ಫಸ್ಟ್ who suggested or who said regarding the interaction of the charged particle or charged body and the behavior of the electric and magnetic field in the macroscopic level. So he was the one who suggested or who gave the idea first regarding the interaction of the charged body and behavior of electric and magnetic field. Okay, so he was the one who suggested first regarding the interaction of the charged body and the behavior of the electric and magnetic field. So according to the Maxwell, what he says, when any charged particle moves see here, when any charged particle moves under acceleration, alternatively electric and magnetic fields are produced. When any charged particle, suppose you consider any one of the charged particle is there, if it moves under the acceleration, it can able to produce the electric and magnetic field. There is a alternative electric and magnetic fields are produced and those are transmitted. These fields are transmitted in the form of wave. These waves are called as electromagnetic waves or electromagnetic radiation. So let me write the point first, then I will clarify that point. When an electrically charged particle moves under acceleration, alternative electric and magnetic fields are produced. Electric and magnetic fields are produced and transmitted. And these fields are transmitted in the form of waves. These waves are called as electromagnetic waves. Or radiations, electromagnetic radiations. Okay, so first point we are discussing about the Maxwell's wave theory anna theory, or else it is also called as Maxwell's theory of electromagnetic radiation. So we are using the term electromagnetic radiation. It means we need to know what are electromagnetic radiations. Okay, the Maxwell was the first scientist who gave idea about the interaction between the charged body, ಯಾವುದೇ ಒಂದು charged body ನಾವು interaction ಮತ್ತು electric and magnetic field ಆ ಬಾಡಿ ಮೇಲೆ ಯಾವ ರೀತಿ ಬಿಹೇವಿಯರ್ ತೋರಿಸ್ತಾವ ಅನ್ನೋದನ್ನು ಫಸ್ಟ್ ಸಜೆಸ್ಟ್ ಮಾಡಿದವರು ಮ್ಯಾಕ್ಸ್ವೆಲ್ ಅವರು. Okay, so the Maxwell suggested that when an electrically charged particle moves under acceleration, ಈಗ ಒಂದು ಇಲ್ಲಿ electrical charged particle ಒಂದು acceleration and it is moving under the acceleration means alternative electric and magnetic fields are produced. Alternative electric and magnetic fields are produced and those are transmitted. ಸೊ ಯಾವ ರೀತಿ ಟ್ರಾನ್ಸ್ಮಿಟ್ ಆಗತ್ತವು, ದೀಸ್ ಆರ್ ಟ್ರಾನ್ಸ್ಮಿಟೆಡ್ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ವೇವ್ಸ್. ಸೊ ನೀವು ವೇವ್ಸ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿರ್ತೀರಿ. ಸೊ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ ದಿ ವೇವ್ಸ್ ದೋಸ್ ಆರ್ ಟ್ರಾನ್ಸ್ಮಿಟೆಡ್. Those waves are called as electromagnetic waves or electromagnetic radiations. I hope so it is clear. Simple. ಯಾವುದೇ ಒಂದು ಎಲೆಕ್ಟ್ರಿಕಲ್ ಚಾರ್ಜ್ಡ್ ಪಾರ್ಟಿಕಲ್ ಅನ್ನ ಒಂದು ಎಕ್ಸೆಲರೇಷನ್, ಇಟ್ ಈಸ್ ಮೂವಿಂಗ್ ಅಂಡರ್ ಎಕ್ಸೆಲರೇಷನ್, it can able to alternative electric and magnetic fields are produced there, and those are transmitted. How those are transmitted? In the form of the waves, and those waves are called as electromagnetic waves. Those waves are called as electromagnetic waves. Okay, so this is the point which was given by the scientist Maxwell. So let us discuss about according to Maxwell's wave theory of a light. He has studied about it and he has given certain points. So according to the Maxwell wave theory of a light, so what are the points? So let me explain you first. First I will write, then I will an oscillating, shortly I am going to write oscillating electrically charged particle can produce electric and magnetic waves which are perpendicular in direction and also perpendicular to the direction of the wave, and also perpendicular to the direction of the wave. Next point, these electromagnetic radiations does not require any material media. These does not require any material media for propagation. Even they can travel in vacuum. They can travel in vacuum. Okay. And the third point, there are many different types of the electromagnetic radiations are there. Which are those? There are many different types of electromagnetic radiations are there. Includes X-ray, UV rays, radio waves, etc. Okay, and these electromagnetic radiations move with the same velocity. These move with the same velocity. These all electromagnetic radiations move with the same velocity of light, that is the velocity of light is 3 into 10 to the power 8 meter per second. Meter per second. See here, for now I will explain about these points. Oscillating electrically charged particle can produce electric and magnetic waves. electric and magnetic waves which are perpendicular in direction and also perpendicular to the direction of propagation of wave. Direction of propagation of wave. See here, suppose any one of the charged particle is there which is oscillating, it means which is in the oscillation. It can able to produce like this, electric and magnetic waves like this. It can able to produce electric and magnetic waves. These electric and magnetic waves are perpendicular to each other. Even these are perpendicular to the direction of the propagation of the wave. So wave yav kade propagate agakateti adukku perpendicular irtavri plus av erdunu each other perpendicular irtavo. Artha agatati na helatiರೋ point. See here, it cannot be shown on the board. Board ಮೇಲೆ represent ಮಾಡಕ್ ಆಗುದಿಲ್ಲ, ಯಾಕಂದ್ರೆ ಮೂರು ವೇವ್ ತಗೋಬೇಕು, x, y, z axis ತಗೋಬೇಕ್ರಿ. Okay, so it is 2D representation. Just for your understanding the concept, any electrically charged particle can produce electric and magnetic waves. Electric and magnetic waves, these electric and magnetic waves are perpendicular in direction and also perpendicular to the propagation of the wave. Clear? And then these electromagnetic radiations does not require any material media like sound waves. Sound waves require material media, but electromagnetic radiations does not require any media for the propagation, and they can also travel in the vacuum also. And there are several types of the electromagnetic radiations are there, which are those which includes X-rays, gamma rays, UV rays, radio waves, IR waves, etc. And all these waves are having the different velocity, that one different etc. These are having the different velocity, wavelength and wave number Okay, and the last point, these all electromagnetic radiations moves with the same velocity, that is equals to the velocity of the light 3 into 10 to the power 8 meter per second. So any electromagnetic wave can be represented like this. So see here, any electromagnetic wave can be represented like this, and here the electric and magnetic fields are perpendicular to each other, and even those are perpendicular to the direction of the propagation of the wave. Okay, so today we are discussing about the developments. Developments leading to the Bohr's atomic model as well as Maxwell's theory of the, that is wave theory. Okay, so Bohr atomic model is nowadays we consider it is a standard model, but before during the discovery, what are the points lead the scientist Bohr to propose his theory? See here, he just observed the interaction between the matter and radiation, how the interaction is there, that also contributes the structure of an atom. And then two major developments here to develop the Bohr's atomic model. The first one is the dual character of electromagnetic radiation. So now I have explained here what is electromagnetic radiation. So the dual character, electromagnetic radiation can also behave like a wave, even it can behave like a particle. Two nature, two is nothing but that is dual. The term dual is used, even it can act as a wave, even it can act as a particle. Okay, and one more point which includes the major development, that is atomic spectra. Okay, that will come further, that we will discuss regarding the atomic spectra. And then now we are talking about the electromagnetic radiation. So the scientist Maxwell, he was the first who explained about the interaction of the charged bodies and the behavior of the electric and magnetic field in the macroscopic level. So here, next, what is suggested when an electrically charged particle moves? When an electrically charged particle moves under the acceleration, the alternative electric and magnetic fields are, that is fields are produced and transmitted. These are produced and transmitted. These transmitted, that is, these fields are transmitted in which form? In the form of wave. So we are studying here the electromagnetic radiation behave like a wave. We are discussing here the electromagnetic radiations behaves like a wave, and these fields also transmitted in the form of wave, and these waves are called as electromagnetic waves, or also called as electromagnetic radiations. Okay. So this is the points which was given by the Maxwell. So later few of the points according to the Maxwell wave theory of light, we can able to give few, we means the scientist Maxwell, we can able to study. So what is that? The first point, oscillating electrically charged particle, any particle which is oscillating, which is electrically charged particle, it can able to produce electric and magnetic waves. And those electric and magnetic waves are perpendicular to each other and also perpendicular to the direction of the propagation of the wave. So illondu electrical charged particle move agakatete andre illi produce aguvanta electric and magnetic waves enagirtavri eradu perpendicular irtav, plus this is perpendicular to the direction of propagation of the wave. One wave ee riti move agakateti, ee riti move agada ee propagation gunu perpendicular irbeku, plus electric and magnetic fields enagirbekrri perpendicular irbeku. Okay. So that was the first point. And the second one is, these electromagnetic radiations does not require any material media. They can even travel in the vacuum, but sound is not produced or it is not transmitted in absence of the media. Okay. Media must be there, but here our electromagnetic radiations can travel even in vacuum. Those does not need any material media. Clear? And next one is, the many different types of the electromagnetic radiations are there, which includes X-rays, UV rays, gamma rays, radio waves, IR rays, etc. And these all electromagnetic radiations having the different wave number, different wavelengths and different frequencies, all are having the different properties we can able to say, or different characteristics, even though all these are the electromagnetic radiations, but the properties are different, like wavelength or frequency or wave number, those are different. And these electromagnetic radiation move with the same velocity, that is the which is equal to the velocity of light, that c is equals to 3 into 10 to the power 8 meter per second. And if we represent an electromagnetic radiation or electromagnetic wave, how it appears? It will be like this. It will be like this. So this is how we can explain about the ideas of the electromagnetic radiation according to the Maxwell. According to the Maxwell. So his contribution was very important, because here we came to know that what is the electromagnetic radiation and how the electromagnetic radiation behavior, how it moves in presence of media or in absence of media, and how many types of the electromagnetic radiations are there, and their characteristics we will study. What is wavelength, what is wave number, what is frequency, what is velocity, that we will study further. Those concepts will also be there, and problems on that also be there in your syllabus, that we will teach you again. And this is clear for you, I hope it is clear for you. Simple concepts are there, only the thing you need to understand. Okay. So first one is the ideas, the developing ideas for the Bohr's atomic model that we discussed, and majorly there are two important developments, that is dual character of the electromagnetic radiation and then atomic spectra. And later on we discussed about the Maxwell's wave theory and what he suggested, and the definition of the electromagnetic radiation we studied, and what are the, according to his theory, what are the points he explained that we studied. So let us discuss about the electromagnetic wave and characteristics. So here, suppose if I represent the electromagnetic wave in this way, for in order to understand all these characteristics. Suppose this is the electromagnetic wave, even it will be like this only. Alternative electric and magnetic waves will be there. For our convincing or for understanding the terms, that is characteristics of the electromagnetic wave, we are going to draw like this. And these upper parts or peaks are called as crests. These are called as crest, and this lower is called as trough. This is called as trough. Okay, and this is the direction of the propagation of the electromagnetic wave. And then here electric and magnetic fields both are perpendicular to each other, and even it is perpendicular to the direction of the propagation of the wave. Okay. So, let us go for the characteristics of the electromagnetic radiation. So, there are certain terms which you need to know, and the formulas are also very important, because the problems, that is numericals, will be there based on these formulas. So, first one is wavelength. Wavelength is represented by lambda. It is called as lambda. And what is wavelength? Wavelength is the distance between the two successive crests or troughs. Wavelength is the distance between the two successive crests. So, successive terms why I am using, you should use the next, immediate next crest only, the distance between the two successive crests or the distance between the two successive troughs, you can take here also like this. If it is trough, means this distance is lambda and this distance is lambda. So, what is wavelength? Wavelength is the distance between two successive crests or troughs. Okay. And the SI unit of the wavelength is, SI unit of the wavelength is meter. SI unit of the wavelength is meter. It means wavelength can be represented in terms of the meter. Even it can be represented in terms of the nanometer. Even it can be represented in the term of the angstrom. So, 1 nanometer is equals to 10 to the power minus 9 meter, and 1 angstrom is equals to 10 to the power minus 10 meter. So, for the problems you need to remember this. 1 nanometer means 10 to the power minus 9 meter, and 1 angstrom means 10 to the power minus 10 meter. Okay. And next, wave number. Wave number is represented by nu bar. It is like this, nu bar. Wave number is the number of the wavelengths per unit length. Per unit length. So, the wave number is reciprocal of the wavelength, that is nu bar is equals to 1 by lambda. Nu bar is equals to 1 by lambda. So, its unit is per meter. Unit is per meter. So, what is wave number? Number of the wavelengths. Number of the wavelengths per unit length. One unit length olaga ಎಷ್ಟು wavelength ಬರ್ತೈತೆ ಅನ್ನೋದನ್ನ ಏನಾಗಿರ್ತೈತ್ರಿ wave number ಆಗಿರ್ತೈತಿ. So, these are the two terms which we have finished. And next, frequency. So, frequency is represented by nu. It is represented by nu. So, frequency is nothing but the number of waves passing through a given point in unit time. The number of the waves passing through a given point, a number of the waves, how many waves are passing through a given point in unit time, and the frequency formula is nu is equals to c by lambda, where c is the velocity, lambda is the wavelength, and it can be expressed in terms of the its unit is hertz. or per second, even you can use per second. Okay, mainly hertz we are going to use. So, what is frequency? Number of the waves passing through a given point in unit time. Next, velocity. Velocity is nothing but the distance travelled by a wave in 1 second. The distance travelled by wave in 1 second. So, what is the formula? So, if you just look at this, C is equals to nu into lambda, that is frequency into wavelength. Frequency into wavelength is the formula for the velocity. And what about its unit? Meter per second. Unit is meter per second. Okay. So, last one more is amplitude. Amplitude is nothing but it is the height measured from center line to the crest or trough, to the okay, and it determines intensity or brightness. Intensity or brightness. Okay. So, these are the terms which we are using for the which we are taking as a characteristics of the wave. First one is wavelength. Wavelength is nothing but the distance between the successive crest or troughs is called as wavelength, and it is SI unit is meter. Even it can be expressed in terms of the nanometer, even it can be expressed in terms of the what we can say angstrom, and 1 nanometer is equals to 10 to the power minus 9 meter, 1 angstrom is equals to 10 to the power minus 10 meter. For the numericals you need to remember this, and wave number is nothing but number of the wavelengths per unit length, that is it is reciprocal of the wavelength. Nu bar is equals to 1 by lambda, its unit is per meter, and wavelength is having the meter means its reciprocal means per meter. And next one is what we can say frequency. It is represented by nu, the number of the waves passing through a given point unit time. In a particular time, how many waves are passing through a given point, that contributes to the frequency. Okay. And then it is the formula nu is equals to C by lambda, and the unit of the frequency is hertz, and sometimes even it is represented to the per second. It is represented in terms of the per second, and the velocity is represented by C. It is the distance travelled by a wave in 1 second. Velocity is nothing but distance travelled by the wave in 1 second, and its formula is equals to is C is equals to nu into lambda, that is frequency and wavelength multiplication can give the velocity value, and its unit is meter per second. And the last one is amplitude, represented by the A. It is the height. It is nothing but height. It is the height of the wave, we can say. It is the height measured from the center of the line to the crest or peak is called as amplitude. It represents intensity or brightness. Okay. So, these are the terms which we are using for the numericals, and these are also considered as a characteristics of the electromagnetic radiation. I hope so it is clear for you. In one more video we will discuss about the numerical part on these all formulas. Okay. Thank you.